Video 2. Functions and mappings. Functions describe how one quantity relates to another, or a connection between sets of numbers. A function is a relationship between two sets, in which each member of the first set is connected to exactly one member in the second set. So, for example, we're used to dealing with x and y. So the numbers we put in are called x, and the numbers we get out are called y. And we can use a function to connect x to y, and we draw it with a little arrow, f. You can treat this like a sausage machine. You've got something you put in and something you get out. This is the input. In the middle you've got a process here. That's your function, and an output. Numbers in, numbers out. Meat in, sausages out. Now, we can use y, or we can also say that y is equal to f bracket x, or f of x. So functions can be illustrated in three ways, either by a formula. For example, a function formula may look like f of x equals 3x. It could also be an arrow diagram. An example of this would be f colon x arrow 3x. So this means x maps to 3x. So if you put x in, you get 3 times x coming out. There's another way we can do this on a coordinate diagram. Formula, arrows, and coordinates. So that means drawing a graph. On the next page we'll draw the graph. So instead of having f of x equals 3x, we could say this is a straight line graph of y equals 3x. So that means you can draw a graph of a straight line looking like this. Y equals 3x represents the connection between x and y. Or in the y-axis we could call this y equals f of x. So if you put in the numbers x, you get 3 times that coming out. For example, if we put in natural numbers 1, 2, 3, 4, operate the function f, we get 3 times these numbers out. So 1 corresponds to 3, 2 corresponds to 6, and 3 maps to 9, 4 maps to 12. So it connects all of the numbers in to all of the numbers out. The numbers in are called the domain, and the numbers out are called the range. Now I'm going to show you some more examples. If we take the function f of x equals x add 2, the set of numbers n we can have as 0, 1, 2, 3. Operating f on these numbers means that 0, 1, 2, 3 in the domain map to numbers in the range. So 0 maps to 0 add 2, which is 2. Now we take 1 and we add 2, which is 3, 4 and 5. Now this is a basic example, but if the function was more complicated, we can write f0, that means x is 0, so x is inside the bracket here. Now we write 0, and we substitute 0 where we see the x, that's 0 plus 2. So that means f of 0 equals 2. We'll repeat this process for each number going in or in the domain. So f of 1 is equal to 1 plus 2. So f of 1 equals 3. F of 2 is 2 plus 2, 4. And f of 3 is 3 plus 2, which is 5. So that's how we get the numbers out. 2, 3, 4, 5. Just taking each number from the domain and substituting it into our function. Now we're going to look at the example from page 5 on your notes. Page 5 gives us a function f of x equals 2x squared plus 1. So we're given the numbers in the domain are negative 1, 0, 1, 2 and 3. So we're going to take those numbers and work out what the range is. If f of x equals 2x squared plus 1, take the first number in the domain, which is negative 1, and put it inside the brackets. This means we're going to evaluate the function when x is negative 1. 2 times negative 1 squared plus 1. Work this out. So 2, negative 1 squared is 1, plus 1. 2 times 1 is 2, plus 1 equals 3. Now it's possible to do this without a calculator, just do it step by step so we get the correct answer. Now 3 is the first number we need for our range. These are the domain numbers, and the range we're doing step by step. First one is 3. Next one, we take 0. F of 0 is 2 times 0 squared plus 1. 2 times 0 is 0 plus 1, which is 1. 1 is the second number in our range. Next number is f of 1. 2 times 1 squared plus 1 is 2 plus 1, 3. 3 again. So we've already got 3 written down here in our range, so we don't need to write that twice. We'll just write the 3 the once, because if you substitute negative 1 or positive 1 into the function, we get the mapping onto 3. Now that's acceptable, that both negative 1 and 1 both give out the same answer. You can draw another diagram to represent this in a minute. Next one is f2. 2 times 2 squared plus 1. So 2 times 4 plus 1 is 9. Is another number. F of 3 is 2 times 3 squared plus 1. So 2 times 9 plus 1 is 19. Now these are the values for the range. Now it would be more sensible to have these numbers written in the correct order, in ascending order. So I'm just going to swap the order of the first two. That's more sensible. 1, 3, 9 and 19. And the values for the range. So drawing a diagram, the numbers in are -1, 0, 1, 2, 3. And the numbers out are 1, 3, 9 and 19. So if we insert -1 into the function, we get 3. Draw -1 with an arrow going to 3. If 0 goes in, we get 1 out. Draw the arrow. 1 goes in, we get 3 out also. So map this onto 3. 2 to 9, 3 to 19. So all the elements in the domain map to one element in the range. So all the numbers that you put in have a value when they come out. It doesn't matter that 3 is mapped onto twice. This is not important. So we can represent this on a graph. It's been done for you on page 6 already.